I'm Mark Nadal. I'm founder of Excelsior, and I specialize in synchronization technologies. So I help startups make sure their data and even their code is anywhere they want it. And I'm an open source enthusiast, so you should go check out my stuff on GitHub. So my talk is going to be on practical philosophy, and with a bunch of engineers, I'm sure I'm seeing you guys cringe when I bring up philosophy. But in this talk, I hope to show you guys that it's for good reason. So I love to start with just an overview of computer science, which is a true programming language, is a Turing-complete language, and that's named after Alan Turing, who's awesome, notably a mathematician. And people don't really like mathematicians. So the best explanation I've heard of what a Turing-complete system is that it turns out that Alan Turing was implemented inside of Julian Assange, who happens to be the same as Sherlock Holmes, compiled within Stephen Hawking. Or otherwise, Benedict Cumberbatch happens to be the only Turing-complete actor in Hollywood. Thanks for the laugh. But if we can't stand mathematicians because they keep on trying to abstract things away from what you like of practicality, we'd wind up killing philosophers. So who wants to drink the hemlock? So why is this important to think about code in abstraction? Because it eliminates a lot of pain. And this is pretty straightforward. If you build your app starting with the lowest level of abstraction, and you think about it in those terms, those basic primitives, and you layer up, it makes development a breeze. If you don't, you're kind of get something kind of morbid. If you use a framework which has assumptions and doesn't do this layering process, you're really excited because until 2 weeks or 3 months in, suddenly that framework turns on you, and you're like, oh, shoot, I can't do what I needed it to do. So you either have to abandon the framework and write your own, you have to savage the code and try and edit it, which usually doesn't go very well, or you have to completely restrict your application to the limitations of the framework. So the process I'm showing will help you get around that. So how do you start implementing that with the primitives of code? I see code, especially JavaScript, as just being 3 fundamental things: communication, data, and manipulation. Essentially, you want to communicate data in, you want to manipulate it, and then communicate data out. And that's your 8 primitives: Boolean, number, strings, arrays, loops, if statements, and functions. And so from this, you can implement basically anything and everything. You can implement Alan Turing inside of Stephen Hawking. It's Turing complete. So if you can make the universe inside of Minecraft, if you have enough RAM, then you really should be thinking about these as your base, which I know you guys do. So where do we start? I'm going to introduce my open source library theory, which does a couple things. It, first of all, has universal normalization. So I'm talking about whether I'm using IE6. Yes, I said IE6. Or Node, or a phone, or the latest Chrome. I know it's going to work. No matter what type of code I wrote, it's solid performance. So I don't have to worry about, does IE6 have map function, or the each? The other thing, of course, is, well, if you have code, you want to manage the code. I know there's a bunch of other things, but we'll get to that later. I'll just show that later. So, and the main inspiration from my library was deep existence and access. So all the time, when I was younger with some bad code, I would try and access some property on some object, and of course that object wasn't defined, and my whole program would crash. And it's like, ugh, JavaScript, why? So I wanted a wrapper that would make it elegant to access those things without having to worry about your computer program crashing. So just npm install theory, and it's basically your natural closure, except for with an extra sandwich. So if you see, you have your closure inside, but above that, the module.exports equals theory. That's just requiring it. This works both client-side and server-side, and allows that whatever you write with inside of your closure, when you return it, it just automatically becomes its own module. So it's super easy. This works with all the other NPM modules out there. It works with whatever, so it makes it easy to throw things around. You can declare your dependencies below in an array. There's an alternate format, but I'm going to jump here back over to this, and I'll just show you that hello.js is exactly what you saw. I'm going to run it. Oops. And you see it says hello world. In the case you don't know what world is there because it's coming from the world file, and that just happens to be, it returns world, and module exports it out. Oh, right. So the first parameter that you get with inside of your callback is theory itself, and that holds all of the modules that you've required. So that's your namespace. All right. That also works on the browser if Control-Alt-J? Yes. So if you see in the browser, it wound up importing everything in and then constantly log hello world out. Pretty awesome. So same code's running on both server and client. So let's jump back. I don't use Mac, so this. What about underscore and require JS? Underscore is great. Theory is more type checking strong, but it doesn't have all the map functions underscore. So use underscore with theory. Require JS, I'm glad they made it, but it's just horrible. I'm sorry, because it overwrites Node's native require function, so I just don't think that's good. But that's my personal opinion. I'm going to skip this slide because it's really not important. Just a joke about me wanting to perfect everything as a philosopher, but then that takes forever to do. So I'm encouraging you to take the right pathway, even if it takes a long time, but I understand that you should take the right path. So when do we get to the cool stuff? Express is great. I want to make that disclaimer. But there's some things that I only used it for maybe a matter of months and then had to move off. So I'm introducing another library, coalesce, which is as easy as npm install coalesce. And then I'm going to just run it really quickly like that. And we're going to do this 8-line code, an upgraded hello world. So let's bounce back, and ooh, can everybody see that?
Yeah.
Oop. Okay, so I'm just going to run. I'm inside of the coalesce, which I installed, so I'm just running its default thing. Localhost. Don't want to get there. We'll get to that later. So this is a. Where is my other window? Macintosh is strange. Sorry. Okay. Can open that in a new window and just throw it over there. All right. So I'm going to show you what I'm going to get into the code after I show you what it does. It's pretty easy. Just synchronizes stuff, and that's all done in 8 lines of code. Pops it between the two. Oops. So let's pop back. OK, so how does it work? We have our sandwich wrapper, which is our closure, using specifically theory. And then our module has the namespace of hello. And we get the parameter, the first parameter is theory itself. And can I highlight? Does that show up? OK. Theory comes with a default module called communication. So that's accessed at a.com. And naturally, that just sends things. So the payload is world. And so it takes a special object that has who, what, when, where, why. That's the API that it has. And so the actual payload is what. And then where is this magical thing that allows you to automatically broadcast or subscribe to something. In this case, I'm both broadcasting to the magic channel, and I'm also subscribing on to the magic channel. And now remember, the next line is we return this function here. And remember, whatever we return from within inside of a closure gets module.exported out as its own module. And at the same time, I'm assigning this function that we're exporting out to, I happen to have in my HTML page an input that is accessed directly to the DOM at hello.to. And I'm assigning key up on that to this function, which is the same thing that we're exporting out. And in this case, when you're doing key up, you're receiving the event, which I'm just calling as the message. We check to see if the event message has a what. It doesn't, so we skip past that. And we're going to do a communication send again. And what are we going to send? We're going to send the value of that input field, and we're going to send it to the magic channel. And so what coalesce automatically, and that was basically when you were typing, it would do, well, never mind. And so what coalesce is going to do is it's going to automatically relay that out to all the other people. And then is going to send that message back into the module which was exported out. So that's actually retrieved, again, right here. And so M now is that payload, is that message that we sent out. So in this condition, it's no longer the event, it's now the message, and we do happen to have a property of what on it, because that's what we sent back here on the other tab, or the other window, or the other computer. So this ternary is true, and so now what we're going to do is, instead of sending the value of the input, we're just going to assign the payload of that value to the input, and thus you get that real-time. You type in one input field and it shows up on another tab. Pain, gone. 8 lines of code and you got dependency management, you got real-time synchronization. It's awesome. So you might think that that has a lot of assumptions, but I'm trying to give you the crude primitives to that, and then you build on top of that to create something which is avoiding those assumptions, so when you layer on top, you don't wind up having that situation where you're like, I want to dive back down, but that means ugliness and that onion nastiness. On top of that, you then combine multiple of those modules together and you create a superstructure. And so as a result, using these really fine-tuned, low-level abstractions, and as you layer up, you can create this really wonderful emergent behavior from all these different pieces that come together. And it borrows the narrative from journalism, which is who, what, when, where, why. That's about the only assumption that comes with Coalesce as a framework. Or I like to call it a library. But if you don't like that, you can pretty much ignore it, and it's just going to automatically work for you. So best part of the speech, where I get to say, unleash the Kraken. So I'm going to do another example, which is a synchronized to-do app in 200 lines of code. So let's... jump to that. I was going to demo this with IE6, and it was working, but then I had to, then Windows didn't work. Windows itself didn't work to hook up to the, so, but then I don't get to shoot myself in the foot doing IE. Okay, so I'm gonna just create, sign up, oh, I need to run the server. Okay. So let's reload and reload. Happiness. Okay, we're in. I'm going to add something to the to-do list. I'm going to log in over here. And when I add here, it synchronizes there. When I update this, it synchronizes there, and I can, you know, it's cool. So the next demo is the Kraken demo, which isn't actually as cool as what it sounds. Whoops. Ooh, that's not gonna, I might have to skip on it. So basically, it's decentralized storage. It uses local storage. So I'm going to create a secret message, and that secret message will, how do you, there. The secret message gets encrypted and then relayed to the server. The server doesn't store it. It relays it to all the other pages, all the other browsers that are on that page, and it stores it there. So now, if I reload, that data will persist when I log back in. So you can see that, so now when I log back in, the data is there. But what should happen is if I exit the page and reload, that node that was a storage unit went offline. So I shouldn't be able to, see, I don't get access to that data. But if I reload it, new tab, if I reload it, it should, boom, it reappears, because it's actually literally that other client which is storing the data, and as soon as it comes online, it pushes that encrypted data back out to whatever client winds up having it. So that's completely like peer-to-peer, except for the server, which is a relay server. It doesn't do anything. And kind of showing the power of what you can do with just 200 lines of code. It's pretty awesome. So because you don't have these assumptions, you can create these really different emergent behaviors, whether that's a to-do app that has 200 lines of code, which is running on the server and the client. You don't want to do that in actual production, but just for the experiment. It works on both sides, and that's just really neat. Or if you don't even want a server, you just want to send the data, and I call that Kraken because when the Kraken comes up to eat the ship, there's all these tentacles that seem to be completely separate, but underneath the water, they're actually merged together, and that's kind of what I view as distributedness. So you can do completely different projects. You're not restricted to those assumptions. Meteor's awesome, it's cool, but it's also kind of assumption ridden. So here's the thing, is if it does exactly what you want, definitely use it over this, because it's going to be way faster. But in 2 weeks to 3 months, if it doesn't do what you want, you're going to have that onion attacking you. So I just want to draw. OK. So what's next? I'm moving to Silicon Slopes, which is Provo, Utah, or Salt Lake City. So say goodbye to me. I'm open sourcing more libraries, something built on top of jQuery, which makes it amazing to handle leap events, touch events, keyboard events, mouse events, everything that you want. That's not very, the JavaScript DevOps and deployment's not really true. I suck at that. I need somebody to help me with that. And then my regular startup. And then I could do a completely separate talk on my algorithms for synchronization. They're a little bit different than operational transformation, but of course, yeah, but that'd be a completely separate talk. And that's all these libraries. The reason why I'm building, they're all going to culminate up into what I call a tactile spatial programming language. I'm just going to leave that as mysterious because I haven't gotten there yet. So before we get to everybody's favorite part, I just want to encourage everybody to kind of rethink that pesky philosopher or that mathematician that's always spouting all this philosophy and abstraction. You're like, no, 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 I just need to get work done, practical things. Because if you take those principles, if you take those philosophies and build on top of them, you can create these really rich emergent behaviors in very small amount of code, but you don't wind up getting restricted in any way, shape, or form because you still get access to those raw primitives, and that's what I'm trying to do. So, thank you. Questions?
Where can I see some of this on GitHub?
GitHub.com/Mark.
Cool. And what's on there?
Right now, Theory's on it, Coalesce is on it. I just uploaded some other things. So there's about 9 libraries, but I only have like maybe 3 or 4 of them up. I also have a MongoDB driver from Node, which I wrote a long time ago before the other ones were out. But there's various stuff. Pester me, and then I'll add more stuff. So.
Are you using WebSockets or WebRTC? How are you using?
I was using Sock.js, so it's going to fall back. But I mean, what I haven't done yet with Coalesce, it's still kind of experimental, but I want people to play with it and give me feedback. I do need to allow people to plug in their own thing. So if you don't want to use Sock.js, that I believe should be something that can be easily, within just a couple lines, swapped in with Socket.io or native WebSockets.
My own experience, it seems like a lot of the frameworks, you first use them just because of the fact that they have a wide level of enterprise adoption, and like they sort of have a track record and a large community like behind them. And it's kind of risky sometimes when you go in and do your own thing, and you don't know if that's still going to be there, if it's still going to be supported, if the developers are going to say, you know what, I'm going to do this, goodbye.
Right.
How do you go about judging when you're saying, okay, this is going to be the job, this is what I want to get done? What are some of the things that go through your mind to kind of to judge that this is lightweight, this is the one that's going to do the job versus this is the one that everyone else doesn't need?
I don't really have a team, so it's kind of just me. So the solution is I'm CEO and CTO. Yeah, So I don't know. Even if you're going to use something really popular like Angular or Backbone or that stuff, you're still going to have to pitch the upper ups in your company. And even if it's hugely supported or popular, there's no guarantee that they're going to even accept that. So yeah, I totally understand that. Yeah. Does that answer your question, or?
I was curious, like, what you're thinking. So, like, how would you say, like, is there like a something? When do you start noticing that I work with a couple people here. How do you know your framework's too heavy or your framework is holding you back? When is the point if you're like, is it?
Oh. For me, it's because it's super, super exciting, but then literally within weeks or a couple months, I want to do something and it just won't allow me to do that because it has that assumption. And at that point, like I said before, I either have to swap out or be restricted to it or savage the code. So for me, that's when I can tell I want to do something, I try and do it, and it just doesn't work. I don't know if that's helpful. Yes?
Are there any libraries that build upon this theory library?
Sorry, say it again?
Is there any other library that is based on this theory library that we can?
Are there any libraries that are built on top of theory? So all of my libraries are built on top of theory. So Coalesce builds on top of theory, which is creating that layering structure. Other than the stuff I've done, not that I know of, there's one guy who messaged me and said that they were using it. But I just kind of announced this formally like pretty recently, so it hasn't had enough time to really get people using it. But that's why I want you guys to try it out. And then complain when it doesn't work.
All right. Awesome.
Thank you.